Here is just a short review going over acidosis and alkalosis, as well as a few review questions for preparation for the exam on Monday. So, 4 categories of your acid-base balances. You have this in your printed or your PowerPoint lecture notes, but I just thought I'd mention it. Respiratory acidosis, elevation of CO2 due to ventilation depression. Remember that great equation looking at water plus CO2 equals carbonic acid, and then CO2 and water gives you carbonic acid. That breaks down to give you bicarbonate. And if you have an increase in the CO2, it's going to naturally give you an increase in carbonic acid. So if it is respiratory acidosis, the issue causing the acidosis has something to do with the respiratory system, so ventilation depression. The ventilation is being depressed. The patient is not blowing out CO2, so then the plasma CO2, the partial pressure CO2 gets elevated, and you have acidosis that develops. Depression of PCO2 due to alveolar hyperventilation. So the CO2 is staying inside, or being blown off, all right, hyperventilation. You have respiratory alkalosis. You're getting rid of too much CO2, and you're not converting anything into acid, and so then the bicarbonate levels will increase. And again, it's because of a pulmonary issue, so it's respiratory alkalosis. Metabolic acidosis, depression of the bicarbonate or an increase in the non-carbonic acids, and it's going to have to do with something in the body outside of the pulmonary system. So it's a metabolic issue. And metabolic alkalosis, elevation of the bicarbonate, and then your pH goes up. But again, looking at respiratory versus metabolic, something is going on in the lungs with respiratory, something is going on somewhere else in the body if it's metabolic. Again, this is a summary that you have in your PowerPoint slides. But metabolic acidosis, the cause, loss of base, increase in the acid. What happens to your serum pH? It goes below 7.4. And the important thing to think about is compensation versus correction. So if it's metabolic acidosis, the respiratory system is going to try to compensate by increasing respiration and decreasing the PCO2. So increase respiration, you blow off CO2, try to get rid of that acid. The renal system is going to increase the acid titration, right? Dumping acid, dumping your hydrogen. And then the fix, all right? There's some metabolic issue going on. In order to correct it, you have to find out the problem and fix it. Metabolic alkalosis, increased base, loss of acid, pH goes above 7.4. The respiratory system is going to try to compensate. Decrease respiration, hold on to that CO2, create the acid, counteract the base. The renal system can try to compensate by decreasing the acid titration, hold on to the hydrogen, and that allows it to increase acid. For respiratory acidosis, decreased respiration, the body is holding on to CO2. Compensation, the kidneys are going to increase acid titration. Respiratory alkalosis, increased in your respiration, blowing off CO2, decrease that acid, and allow for bicarbonate to build up. Now, the issue between compensation and correction. All right, if the disorder is respiratory in nature, it doesn't matter if it's alkalosis or acidosis. If it's respiratory in nature, It's generally going to be compensated by renal function, and it's going to be corrected by figuring out what the lung issue is and having adequate lung function. If it's a metabolic issue, acidosis or alkalosis, the lungs are going to try to compensate, and then it's going to be corrected by having adequate renal function restored. So, big difference between compensation and correction. You may see that on your exam. Are the two the same? No. Are they equal? No. Can you have one without the other? Yes, because you can have compensation without correction. Generally, if you have correction, your body has already compensated to get you to the point of being able to correct the problem. So, a couple of questions here. When planning care for a dehydrated patient, a medical professional remembers the principal water balance is closely related to what balance? Potassium chloride, bicarbonate, or sodium? We're talking water balance here, and the correct answer is going to be sodium. These are the type of questions you are going to see. All right, next question. A 70-year-old male with chronic renal failure presents with edema. Which of the following is the most likely cause of this condition? Increased capillary oncotic pressure, decreased interstitial oncotic pressure, increased capillary hydrostatic pressure, increased interstitial hydrostatic pressure. All right, there's a lot there. And one thing that you need to pay attention to is you've got a couple of things going on in this answer. Even though I'm not saying which is the correct answer at this point, you've got a movement, increase or decrease. All right, you've got a location, capillary versus interstitial. You have the correct or a particular type of pressure, the oncotic pressure, the hydrostatic pressure. If you were to have to write out an answer, you can't just say oncotic pressure. Just simply writing oncotic pressure doesn't tell me a whole lot. You have to have a location, capillary or interstitial, and you have to have a amount, right? A direction, increase or decrease. So hopefully that makes sense. So what's the answer? All right, increased capillary hydrostatic pressure. So why is that? If you go here, the answer is increased capillary hydrostatic pressure. High pressure here is going to push water out. Right? Hydrostatic, if you think about it as a dam, with water going through a dam, over a dam, the water is pushing the, whatever, I'm having a mind blank, brain freeze here, the propellers or whatever within that dam that is trying to create the electricity. Right? The water pushes those around as the water flows through. So the correct answer is increased capillary hydrostatic pressure. Right? Increased capillary oncotic pressure. What is that going to do? Increased capillary oncotic pressure down here that's going to pull water out, that's going to decrease the ability for edema to develop. Decreased interstitial oncotic pressure. Right? If it's oncotic or interstitial pressure, oncotic interstitial, it's protein in the tissue. Right? What does the protein do? The oncotic pressure, it pulls. So if it's decreased, you're not going to have that pulling effect. If this answer was increased interstitial oncotic pressure, then you would have two correct answers. But it's decreased, and so it's not going to be pulling water out into the tissue. And then increased interstitial hydrostatic pressure. If it's increased interstitial hydrostatic pressure, is going to be pushing fluid back into the capillary, decreasing the development of edema. All right, I think there was one more thing I was going to mention here, but I have forgotten, so we will go on. Oh, I know what I was going to mention. All right, so this question, a 70-year-old male with chronic renal failure presents with edema. You might get stuck there and wonder, get stuck on the 70-year-old male part, try to think about the chronic renal failure component and how that is causing edema. But the real issue here, or the real points to focus on, is edema. This person has edema. Why does this person have edema? And you think about the mechanisms in which edema, how edema occurs, and you just have to look at this. Person has edema. Why? Because there's increased capillary hydrostatic pressure. So don't let this first sentence or this first part of a question throw you off and cause you to lose valuable time during the exam. All right, one reason for a decrease in capillary oncotic pressure would be a decrease in production of plasma proteins, an increase in production of plasma proteins, or venous obstruction. So what would the answer be? You're decreasing capillary oncotic pressure, which means you're losing protein. Right, that oncotic pressure is going to be directly related to the protein volume, the number of proteins in the capillary. So therefore, the correct answer would be decrease in production of plasma proteins. Venous obstruction would cause fluid to build up in the tissue, and so that could provide or cause there to be an increase in interstitial hydrostatic pressure because there's more fluid. It's going to try to push fluid out. All right, but that is it for this short review, and hopefully that gives you a help with studying for the exam or some examples of questions. If you have the study guides, I would look through that. Look at some of those some of those questions, see if you can answer them. Focus on the questions that we have already gone over. There's a lot of stuff in the text that we haven't gone over, and so therefore several or over half of the questions that are in your study guide that we did not cover. Don't worry about those. Look for questions that we've studied that you think you should know the answer for. Just use those as a testing mechanism for yourself. Also about the exam, it will be Scantron, so bring a pencil. And it will be the blue Scantron form, so if there is a question, if there is something on the list of objectives that says list X, list this, those would be where you might find questions that would be on the back of that blue Scantron forms, questions 66 through 75, where you are simply going to be writing answers out. All right, that's it. Good luck studying. I will see you all on Monday.